Quick question. What's the difference between 2 and 2? What's the difference between 2 and 2? Time's up. May I have the envelope, please? That's an easy question like this. The answer is the world. Yes, you see, there is a world of difference between two objects that you can count, and a squiggle that means 2. But it's a bigger world than just 8,000 miles in the diameter of the Earth. It goes for bazillions of years. It's the time as well as the space difference. Because if you go back bazillions of years when the human species was just a little runty, no-cow species running away from lions in Africa, long before we got enough power so we could potentially destroy the entire climate of the globe. In those days, it was really important that you knew how to count. So counting must have been one of the early feats which the human intellect was able to master, long before it was able to master representing numbers with squiggles. So this is a tremendous abstraction to go from objects to a squiggle that means a certain number of objects. But that abstraction is nothing compared to the abstraction of going from a squiggle that represents a number to X that represents any number. So this really is a double level of abstraction. It means anything, and it also means anything that can be written by number. So to have students learn these 2 steps is essential for them in order to them to master higher mathematical concepts. And that's why Mathmagic Blocks is an important tool in your teaching quiver. So the way the blocks works is we have a scale here, 2-pan balance, and for example, we have blocks. We have a 2 and a 3. Well, as you might guess, 2 is not equal to 3. Well, maybe 2 and 6 are equal to 3. No? Maybe 2 and 3 are equal to 5. Because 2 plus 3 does equal 5. So, Mathmagic Blocks, which contain a full set of black blocks, which are good for learning addition, allow students to understand just totally basic concepts of addition. But Mathmagic Blocks goes on beyond that, because you'll notice not only are there black blocks, but there are colored blocks as well. So let's take a look at these colored blocks for a second and see how that works. As you know, 2 plus 3 equals 5. Well, let's take 2 and 3, and let's put a 5 on the other side. 2 plus 3 is 5. Or not. So 5 isn't heavy enough. Maybe 2 plus 3 is 8. No? 4. Yeah, 2 and 3. Well, it's more than 4 and less than 8. How about? Yes, Mathmagic Blocks also teaches multiplication. And because we can say 6 equals 2, 6 divided by something equals 2, it could also represent division. So as such, and with a large number of blocks, kids can have a lot of fun just playing around and seeing what works. And if you want to figure out what balances a 60, well, there's a bunch of combinations, and you can heap a large set of blocks on one side and finally get up to balancing a 60. So the main point of Mathmagic Blocks is for kids to realize that learning can be fun, and that the patterns in nature that are represented by math actually make sense. And they're beautiful because math is beautiful. But if kids are constantly just frustrated because they're trying to cover stuff that they never understood the basics of, then they can't see the beauty. But with Mathmagic Blocks, you open a potential door for them to see, wow, math is beautiful. Recently, I had some kids that were working on building a wooden box. They wanted to make it square, so I said, Well, just write out the dimensions you want me to cut the wood out, and then I'll cut the wood that size. So I cut the wood exactly to the size they wanted. So if 4 pieces of wood are the same size, if you try to build a square that will hold together with nails like that, then you don't get this square. And you definitely don't get a square if this is 4 inches on a side, that is 4 inches on a side. Going like this will be a square in shape, but you can't join the pieces together. So you have to obviously cut 2 of the sides shorter so that the whole thing will make a square. Sounds pretty simple. Well, we had an extensive discussion about this. We measured and found out that this was 3/4 of an inch, and they knew how long they wanted these pieces. At one point I asked them, so how many inches are in a foot? That led to quite a controversy. They debated and couldn't decide because they all had a different answer to that question. Well, in the end I decided this is a learning lesson, and I'd like them to figure out, because they know how to use a ruler, how much smaller they'd have to cut 2 of the pieces so that actually it would make a square. They worked on it for about 10 class periods. Now mind you, these kids have taken algebra. Most of them are in geometry, some are in algebra 2. And I think the main reason for this is they've memorized their way through math. They've memorized a method that helps them to solve this problem without having an overview understanding, without actually having manipulated objects and gotten a feel for how math relates to the real world. And that's the value of Math Magic Blocks, because in Math Magic Blocks, you're actually manipulating numbers and seeing and feeling them and seeing how they compare to each other. Now what that does is it provides a foundation that's so strong that then you can build on top of that all the fancy math that you need to go far. But if you don't have that foundation, then math becomes a sentence which is completed with, that's the subject I'm not good at, or that's the subject I hate, as opposed to math. What a beautiful way to behold the world. Math Magic Blocks.